Hello, my name is Grant Fritchey. Today I'm going to talk to you about using Query Store to understand performance inside your PostgreSQL database. Now, this is really important because unless you know what's happening inside your database and you know how your queries are behaving, tuning those queries and getting them to run fast is going to be really difficult. But Query Store inside of your Azure Postgres database will absolutely help you get it done. Come to the session, find out how. But if you've got questions after today, I would love to help out. And so here's my contact information. Reach out to me. Let me know what I can do to answer any questions that you have. You can get in touch. Thanks a lot. Now, let's get going on the technical stuff. So, query tuning. Query tuning is, what's a good way to put it? Hard. Query tuning is quite hard. You've got to go through a lot of stuff. You want to identify the query that's badly behaving. You want to look at the explain plan to understand what's happening. You maybe have to look at the code to see what's going on there. You've got to do some experimentation to see if you can fix it. Is updating statistics going to help? And what you got to run the vacuum again. What's going on? All kinds of stuff. It's very, very difficult. And then you release it to production. It fixes things. Maybe it does, maybe it doesn't. But after you've released it, then you've got to identify the next badly performing query. And so it always kind of comes back to our start point. Which queries are we going to focus on? That's really the question. That's the big, big question. And so what we want is to have a proactive way to track down these queries, because the last thing you want to do is try to figure out queries just based on, well, I don't know, that one might be slow, or oh, somebody called me yesterday, there was a query that was slow, or the boss, has queries that run slow, so I'm going to go focus on the boss's queries. We really want to get proactive, understand what's happening on our system, understand the queries that are running slow, and then focus on those queries to tune them. Now, before we get going, though, let's talk about a couple of notes on the whole idea of query tuning. Now, the one thing, the most vital thing, we need to have 2 points of comparison. Without 2 points of comparison, you can't start doing query tuning. So when someone comes up to you and goes, hey, that query ran in 15 milliseconds, it's slow. Well, slow compared to what? Right? Slow compared to what they want. Slow, was yesterday it ran in 5 seconds and today it's running in 15, right? We need to know a comparison point. We need to have a before and an after. Before we made a code change and after we made the code change. Before we ran vacuum, after we ran vacuum. Before we added an index, after we added an index. All of these things directly impact performance, but you have to be able to have 2 points of comparison. Otherwise, you're just guessing. And guessing is not how we're going to get this job done. We have to have those comparison points. So those are the two most important things. Next, metrics. Use all the metrics. Are we going to focus on duration? Sure. We're going to spend time looking at duration because, hey, that's an easy measure for performance. Well, yesterday it ran in 5 milliseconds. Today it ran in 5 seconds. Well, I mean, do we need to worry about other metrics? Probably not. But the fact is that you are going to want to make sure you focus on those other metrics. For example, you may have a system that's memory locked, and spending a lot of time worrying about duration may or may not help you. Maybe you need to be focused more on memory metrics and seeing how much memory a given query uses. And remember that any given query may use a lot of memory. It may run fast, so its duration may be very low, but it uses a ton of memory and affects other queries, causing them to run slow because they're memory starved. So you've got to look at that. Same thing with CPU, same thing with I/O. You don't want to get locked on any one metric. You want to make sure you're using all the metrics. Oh, and most importantly, in terms of those metrics, you really do want to focus on execution count. Now, I had a friend, wasn't me. I really wish this was the story about me saving the day, but I had a friend who saved the day. We had a query that was running at about 3 milliseconds. We tuned it, and it was running pretty good, but it was called thousands of times in a minute. And my friend spotted potential fix for that query that got it to run about 30% faster. We went from 3 milliseconds to 2 milliseconds. Now, you could think like, well, 30% improvement, who cares? But when you talk about thousands of executions all day long, we could see it on the system. So focusing on that execution count is really important. Now, next up, we do want to talk about explain plans. We're going to look at an explain plan today. But the thing is about explain plans, we got to be real clear on explain plans. They are an explanation of behavior. They are not themselves a measure of performance. And so you don't want to start looking at plans and saying, oh, poor performance, and let me improve the plan. No, 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 no. Yeah, the plan may suggest that you're missing an index. The plan may let us know that our statistics are out of date. Certainly, the plan is going to give us that kind of information. And then adding an index, getting statistics updated, sure, that may change the plan. But that plan is not a measure of performance. It's an explanation. I mean, it's in the word. It's an explanation of the choices made by the optimizer, and that will help you drive tuning, but it is not itself a performance measure. And then finally, don't forget execution count. Yeah, I know, I already mentioned that one. I mentioned it twice because it's actually very important. The number of times something gets executed frequently has as much or bigger impact as what it is doing when it gets executed. So keep that in mind. Keep an eye on that execution count in addition to measuring, performance and all that fun stuff. Cool. We're level set on query tuning. Let's move forward. Now, we want to talk about query metrics in PostgreSQL. Obviously, we're talking PG stats, right? PG stat tables, PG stat indexes, and heck, PG stat statements. Give me the query information I needed, right? Because that's how we're going to start making those determinations. Which query is slow? Which one do we need to work on? But there's a bit of an issue here. These metrics, as displayed within Postgres, are aggregated. So what's that mean? Well, it means that we don't get 2 points of comparison unless we ourselves do it. If you want to set up something so that you capture PG stat statements yesterday and then capture PG stat statements today, then you've got 2 comparison points and you've got some understanding of what's going on inside that query. Cool. But you've got to build that. And maybe daily is not granular enough. You may need a more granular view. So that's going to be tough. Now you've got to build that in. You got to capture all that stuff. You've got to find ways to put it together. You got to find ways to show it up on the screen. You got to, I mean, there's a bunch of work there. What if you could do it a whole lot simpler? So let's talk about the query store. The query store gives you 3 pieces of information: query statistics, weight statistics, and explain plans. Now, the query statistics gets you is the standard kind of stuff you'd want to see: query duration, averages, maxes, all that fun stuff. But what they do is yes, it is aggregated. Why? Why aggregated? Why not granular? Why not, every single statement? Well, because 99% of the time, 9 times out of 10, that'd be 90%. Regardless, you get the idea. Most of the time, most people in most situations only need aggregate information. But we do need, remember, 2 points of data. Well, Query Store takes that aggregate information it gathers on the queries, all the query metrics, this query ran this fast, all that fun stuff, and then breaks it up into hour-long segments, giving us that one thing that we really, really need: a before and after. What did it look like yesterday and what did it look like today? So we've got that final measure that we need, 2 points of data. That's huge. Now it also gives us explain plans. And the explain plans it captures multiple explain plans. So if there was a different explain plan yesterday for the same query than the explain plan for today, we've got the ability to compare those 2 explain plans and then understand, why did performance degrade overnight? Did, the vacuum didn't run? We had some other problem? Something's gone wrong with statistics. Who knows what it is? But having those 2 explain plans means we can make the comparison that we need to make to understand what's going on our systems. This is a win. Now, it may be that you come in, you look, and you see the explain, it slowed down overnight. You look at yesterday's explain plan, you look at today's explain plan, and they're the same. Well, we've also got the wait statistics. So you can see why things were slowing down in waits, because maybe you're getting blocked by another process. Maybe there's a problem on a server setting or something, and we need to make some adjustments. Well, we can see the wait statistics as well. So we've got all of that information, all of it broken down so that the aggregates, while there are aggregates, those aggregates are broken up into pieces, giving us multiple data points so we can make the comparisons that we need to make in order to do query tuning. Cool. Okay, so how does it work? I mean, how does it, what's it do? Well, I mean, the thing is you get to control it. You get to decide whether or not it's on. So you don't have to use this. I mean, it's a fantastic tool. You'd be crazy not to use it, but you don't have to use it. So you can turn it off and go about your merry way and everything's great. But you can also turn it on and take advantage of it. That's cool. Now, other things you get to control is you get to control the max plan size. Maybe you've got a plan that's just enormous and it's going to take up a lot of resources. You know about it. You don't need to see it all the time. Fine. Let's make our max plan length a little smaller. And so now we don't have to deal with those. We're not capturing them. Same thing with queries. Maybe there's this monster query that runs at 3 a.m. every day, and you don't need to look at it. You know about it. You're going to be able to mess with it when needed and tune it as needed. But we don't want to have to capture it and put it into our systems and worse yet, deal with the fact that it's in there. Fine. We can set the text length as well on the query. Cool. We also get to set the data retention. Now, by default, it's 7 days, but we can set that higher or lower and capture more or less information and keep it around for doing those kinds of comparisons. Because again, what did it look like last week versus this week? Great point of comparison. So you've got that ability. We also can determine whether or not we want to capture plans at all. You could turn off explain plans. If you're saying like, oh, we feel like it might be putting a little bit more of a load in the system. We don't need the explain plans all the time. We'll turn them on occasionally when we need them, or maybe even we'll just capture one as needed. But what we still want to capture query metrics. Fine. Turn off the plans and keep going. And finally, you get to control the capture mode. Now you can turn capture mode to all, which is the default, and that means it's going to capture every query and aggregate them up and feed them back to you for you to consume. Cool, that's great. Or you can capture top queries, queries that are taking longer, using more resources, and being executed more often. And so then you reduce the amount of information you have and get more signal and less noise. Or you can even turn off data collection from Query Store. Keep Query Store in place, keep it on your system, but not capture any queries. Maybe you're doing system maintenance, or maybe you're just trying to take advantage of some of the additional functionality inside of Query Store, which we'll get to a little later. And you don't want to, have to deal with the actual capturing of query metrics, but you still want to get that extra functionality. You could still do that because you can leave Query Store enabled, but stop the data collection. So there's a lot of control that you have over how this thing works. But you know what? The best thing to do, oh, yeah, sorry. Where are we accessing the data from? Forgot about that. There's going to be a database on your servers in Azure called Azure Sys, the Azure Sys database. On that database, there is a schema. Schema is, hey, query store. Hard to understand, hard to read. No, it's really straightforward. And then inside there are a bunch of tables and views, which we're going to hit in the demo and walk through it. So you know what? Let's get started on the demo. All right. Now this is the Azure portal. And on the Azure portal, I'm on the system server parameters for my Hamshack PostgreSQL database. And here, I'm going to just zoom in a little bit so you can see it. We've got, first up is the query store interval. Now, what's that? Well, the way it captures information is it captures it up into memory, and then after 15 minutes, it takes all the memory stuff and writes it out to disk and into those 1-hour segments that you have to look at in Query Store, which we're going to dig into. Don't you worry. We're going to run a few queries. Obviously, you can enable, disable Query Store. You can set the max plan sizes we already talked about. This is where you can control the capture mode, top, all, none. Now, would I recommend switching it to top? No, I would not. I would recommend leaving all the defaults in place initially, unless you know this already really well and you're going to configure it because the way you know you need to configure it for your system. If you don't know it, you're exploring, you're testing, you're validating that's going to work for you. Leave the defaults in place, make adjustments later. Best way to start off, set off with the defaults and then make adjustments. But you can make the adjustments on the, oops, you can make the adjustments on the number of days you capture, whether or not you're capturing plans, and then, obviously whether or not you're capturing utility queries. Again, I left them all on because this is a demo system, but you probably would want to turn off utility queries on your own system. Do you have to? No, of course not. But it might be a good idea to turn those off, just to kind of reduce the overhead. But that's it. I mean, that's how you run this, and it's pretty simple. Now let's go take a look at what it's capturing and how it's capturing it, because that's where things get fun. All right, so here in dbeaver, I've got some queries that we're going to run through, and I've also got the Query Store window open up. Let's take a look here. So as I said, Azure Sys Database and the Query Store schema. Now it's got a number of Query Store tables and views already set up for you. Now the tables are a little hard to use. Personally, I like using the views better as I'm working through it. But you can go directly to the tables to get everything you need. So what you get is obviously plans and text. That's, come on, query text. What do you think might be in there? And then you've got stats definition, the definitions of the stats they're capturing, and then the stats entries. Then you've got the intervals, the values, and some other stuff. But you go down and look at the views, and you've got a query store view, query plans view, query text view, and you can use the views. Again, they're views. You can use them like tables and pull information together. So we take a look at it. We've got some columns in here, and sure enough, we can see all of the stuff going on. Blocks, max time, total time. So you can see what's happening. But let's look at real data. Let's go ahead and run queries. So if we take a look at just the query store texts, and we get, the queries that have been running on the system. And I'll zoom in down here so you can see it. But it's, select star from query store view where I was running this query. So you can see there's a number of different queries coming in. And it lets us know what type of query it is. So if there's some of the system queries or user queries or any other types of queries, you can see those and see what's going on inside your system. So there's the queries. I mean, it's straight up capturing queries. That's cool. Well, now what about stats query counts? Well, this is where things get fun. There is our start time and end time. And yeah, it doesn't start on the top of the hour and then bottom of the hour. It has to do with when your system either failed over last or when you actually launch the system yourself. And so that's when it starts and stops. So these times are not going to be, you know, 1:00:00:00 time to 2:00:00:00 time. Don't worry about it. But you can see the queries that have been going by. You can see the start and end times for those queries. And that's how we start to break things down so we can see, again, before and after. So let's see if we take a look at a view. So what I do is I'm going to go to the query stat QS view, and I'm going to start filtering because just running everything all the time, again, doesn't get us information. So let's go in here and we're going to get SQL text, start and end time, the number of calls, the total time, and the number of rows affected. We're going to look at a particular database, and we're going to look at a particular user ID, and we're going to look at a particular date. Yeah. Oh, wait, no, that's far enough back in time. That would be a problem. Let's go ahead and look at a newer date. Cool. So the query is going to run. It does take a second or two. It's pulling all the information together. I would normally start talking about at that local sports team, whoever your local sports team might be. Give it a second. It's usually about 30 seconds. And sometimes slightly longer. Come on, there it goes. 31. Okay, so you can see Here's the query, and I'm running a very specific query. It's nothing special. I'm pulling together some radio information through a function. But you can see my start and end time, so my 1 hour. In that start and end time, that query was called, can you see it? 500,000 times. We can see the total duration that's running, and we can see, again, the number of rows that were pulled back. So we've got a lot of options going on here. And you can see that there's a whole bunch of other data you could pull together, but this gives you just an overview of what's going on. Well, okay, so what about weight statistics? Well, let's go ahead. Let's pull in the event type. We'll pull them in for the same database, and we'll see what's going on inside there. And so now we can see, there's spin delay, proc array, um, client read, a lot of hits on client read right there. So a number of calls on client read. So now we can see the weight statistics are in there and we've got an idea what's going on. And again, for a particular database, for a particular user. Can we look at it for a particular query? Yes, we can. We can make that combination too. All right, so let's just put it all together. I'm going to create a function. Function is returning a table with some information. Cool. It's basically the core query is going to get the start time, the end time, the number of calls, user ID, database ID. You get the idea. Total time, mean time, standard deviation on the time. Yes, they record the standard deviation. So if you just have the mean, it doesn't tell you enough. Now you've got the ability to do the standard deviation as well. I'm going to join those two tables together. And basically, I'm going to use the compare time um, to pull them together, and I'm going to look for anything where the max time has gone up on a given query. All right, so that's the function, and so we're just going to pull up that function for a given date. Let's go ahead and use this one. Now again, this query, once more, it'll take about 35 seconds. My network has definitely been acting a little funny, but that's how long this query has been running over and over as I've been testing it and getting ready to join you for this great event. But so it's gonna take another 10 seconds here, and then it will finish. So like I said, how about that local sports team? Because we do love the sports ball in IT. I'm kind of kidding. I'm kind of not. All right, here we go. Coming up on 40 seconds, and it's going to finish right there. Oh, come on, you silly thing. Of course, it's running slower now. There it goes. All right, so now what we've got, these are all queries that ran faster earlier. These are all queries that ran faster earlier. So now, just running this query and this query alone, I got a starting point to start to proactively tune my queries. I am no longer guessing. I've got multiple points of comparison. I can bring in explain plans. I can bring in weight statistics. And so I am sure that I can start to really, really tune and identify my queries. And that's the goal here. All right, I'm going to go back to the slides here for a second because there's a little more for you to learn. And that is the weaponization of Query Store. So Microsoft has a couple of things that they've done with Query Store that can help you. And the first one is Query Performance Insights. Now I'm not going to get into them in detail today, but I just want to bring them up so you know that they're there. Now, what's Query Performance Insights? Well, they're taking all of your query store data and then they're running it through an analysis engine and they're bringing up, hey, we think these are your problem queries. We think here are some possible suggestions and here's some things that you could do, maybe get some better performance. Not necessarily carved in stone, not necessarily perfect. You may need to do some testing and validation, but Query Performance Insights will let you see what's happening with all the queries that you've captured in Query Store. Now, I like to dig into the data myself. But I would take advantage of this as a way, especially if you're managing one database, cool. You're managing 1,000 databases, you might want to have somebody else doing some of the analysis to help you out. And so they've done that. Now, the other thing that they've got is this intelligent tuning thing. Now, the intelligent tuning is, again, using Query Store, keeping an eye on plans and statistics and runtimes and all the rest, and using the fact that it has standard deviation and using the fact that it can compare before and after. With all of that, it starts to make suggestions on auto vacuum and some of the other things that you can do to make your queries run faster in an automated way. So you're not actually even having to go in and mess with stuff, add indexes, make changes. So that's really exciting as well. And with that, I am done. If there are questions, I'll be available in the chat. And thank you so much for attending. Really appreciate it. Get out there, use Query Store to tune your queries.